Okay, let's see. Um, so today we're gonna go over chapter 4.1 through 4.3. Yeah, so because last week we didn't, we didn't do pretty much nothing. We did just nothing. So I guess most of you guys just just forget about the stuff what we did on 4.1 through 4.3. So let me review the 4.1 to 4.3. Just give me a second. Okay. So, no, let's see. Okay. All right. So, let's see. So if you can, you can see what my handwriting. Just let me know. Okay. So, so review 4.1. Yeah, 4.1 through 4.3. Okay. So in chapter 4, what we are doing is just study how to solve the second order linear equation, right? Okay. So and then there, and then there are several. We classify the second order linear differential equation with 4 cases. I think 3 cases. So case 1 is homogeneous and then constant coefficient, right? So homogeneous and constant coefficient. So the differential equation has the following form. So in this case, ay dou prime plus by prime plus cy is equal to 0. And then a, b, c are, just constant. And then, so since see that the source function is 0, so this is homogeneous, right? Okay. In engineering, this differential equation is applied to mass spring oscillator, mass spring system, or you can say mass spring oscillators. This is equivalent to what? M y dou prime plus by prime plus ky is equal to x to the first cxt and t. All right. So this is from the Newton's second law of motion, right? And then this is the damping force, right? Damping force, and then this is a spring force, right? So that's my dou prime from Newton's second law of motion. I mean, actually, F equals ma, right? This is from the ma. So, and then the by prime, that's the damping force, and then k times y is the spring force. All right, so now what? Then we just guess the solution, right? So let's say y is equal to, okay, let's say y is equal to e to the rt, right? Okay, and then we put the so r is a real number, so we need to figure out r. So we're gonna plug in this solution into the second order linear, second order homogeneous differential equation. And then we got Ox equation. Remember that? So plug in this, I mean, definitely we're gonna find y prime, y dot prime, and then combining them, I mean, applying them into differential equation, then we get auxiliary equation. So this we got e to the rt, and then a r squared plus b r plus c is equals 0, right? So then e to the rt is always positive for any r. So ar squared plus br plus c gonna be must be 0. So we got the second I mean quadratic equation. So this equation, Ox equation, that's Ox equation. Okay, this is equivalent to quadratic equations. AR squared plus BR plus C. Okay, so this is equals 0, right? So now what? And then yeah, so as you can see that the quadratic equation has three different cases, right? So the first one, the discriminant, okay. Discriminant is greater than 0, and then second one d is 0, and then third one d is less than 0. So if d is greater than 0, then what? These two cases from 4 point, I mean, the section 4.2 cover those two cases. Can you see that? So and then the 4.3 covered the last case. And then d is greater than 0, and then general solution y of t is going to be c1 times what? E to the r1t. Because d is greater than 0 means that this Ox equation has two distinct real roots. So we're going to have two solutions. We can get two solutions. Using two solutions, we could generate the, I mean, construct the general solution, c1 times e to the r1t plus c2 times e to the r2t, right? And then if d equals 0, then y of t general solution going to be c1 times e to the r1t, because d is 0 means that the Ox equation has only one real solution. So general solution going to be c1 times e to the r1t plus c2 times t times e to the r1t, because I told you, we saw that these two guys must be linearly independent. Okay, to so how can you construct the one more the other solution, which is linearly independent to the give me a sec. Yeah, linearly independent to the e to the r1t. We just put t right there. Okay. So give me a second. I think if you cannot hear me, or if you cannot see this handwriting, just let me know. Okay. So okay. So yeah. Give me a second. All right. Give me a second. Our students having trouble to join that meeting, class meeting. So he just sent email to me. So give me a second. Mm, 403-129. C 0470. Okay.
No, if you do, take away your purpose.
Hmm. Oh, weird though. Okay. Interesting. All right, so let me keep going. Okay, so now 4.3. In 4.3, it covered the last case that discriminated less than 0. So then that Ox equation has two distinct complex roots. So the general solution was C1 times e to the alpha 1 t, and then cosine, oh, not alpha 1, just alpha, I'm sorry, alpha t beta t, alpha t cosine beta, right, plus C2 times e to the alpha t, and then sine beta t. This is beta, right? So we see that's what we did. Beta t, and then beta t. Sorry. Okay. So and then here in these less than 0, then R1 was alpha plus I beta, right? And the R2 is going to be alpha minus I beta. Okay. So yeah, let's see example. Okay. So yeah, what I'm doing is to review 4.1, 4.2, 4.3. Keep in mind this. Okay. So yeah, we're gonna see just simple problems in 4.1, 4.2 and 3. Okay. 4.1 is just introduce the motivation of that problems. Okay, in engineering. So I'm gonna give a simple example in 4.2, 4.3. So 4.2. Let's see this one. Let's find the general example. Let's find the general solution. 6y dou prime plus y prime minus 2y. Keep in mind this, all this stuff should be in my lecture note, okay? So, and then sometimes I'll go over some problems in textbook. So yeah, let's find out the general solution of this differential equation. Then what are you going to do? I told you, when you solve the second order linear differential equation, very first step, homogeneous, I'm sorry, is when you deal with the second order homogeneous differential equation, very first step is to find out Ox equation, okay? So step 1 is to find the Ox equation, 6r squared plus r minus 2 equals 0. Does it make sense, right? So we got Ox equation and then try to solve this quadratic equations. So I think we can factor that the polynomial, so 2r minus 1 and then 3r plus 2, isn't it? You see minus 2 and then yeah, right, is equals 0. So we got r 1 half and then minus 2 over 3. Okay, let's see that. Okay. So now, all right. Okay. So now then what? The general solution is going to be y of t. It is going to be general solution is going to be c1 times e to the 1 half t plus c2 times e to the negative 2 over 3t. That's it. It's really simple, right? Okay. So pretty much just two step. Okay. So find Ox equation and solve the Ox equation to find out R and R1 and R2. Sometimes you wouldn't get only one solution in the Ox equation. That's the second case, d equals 0, right? But in this example, is the first case, d is greater than 0. So anyway, so that's the general solution. This is the answer. Okay. So now, next example is for the example. Yeah, next example is the 4y dou prime minus 4y prime plus y equals 0. Okay. Then yeah, just pretty much the same the steps what we did in previous example. So we find the Ox equation, which is 4r squared minus 4r plus 1 equals 0. That's Ox equation. Okay, step 1. Okay, and then step 2, yeah, solve it. Okay, step 2. I think we got to use a quadratic formula. Okay, so R going to be 4, right? Wait, what are they? I think. Give me a second. 4R squared minus 4 plus 1. Oh yeah, so that can be factored as the what? 2R minus 1, isn't it? Square equals 0. Yeah, so this guy has only one solution. R equals 1/2, right? Okay. Then what's the general solution? Y of t. So answer. General solution going to be what? C1 times e to the 1/2 t, and then plus C2 times t times e to the 1/2 t. Okay. So it's the general solution.
I wasn't liking it until I did something here.
What?
Oh, can you hear me?
Yes.
Oh, let me mute it.
Oh, okay. Yeah. Yeah. If you guys have any questions, just tell me or send a text the message. Okay. So using chat. So, yes, the reason that I use the the Zoom, because I told you the Blackboard collaborate sometimes unstable, and then faculties told me that if the number of students the exceeds, I don't know, maybe 7 or 8, then it shut down. So, and then I figured out that Zoom is more stable, and then more optimized to Mac, because I use a MacBook, and the Blackboard Collaborate is not comparable with MacBook. So I got a big problem. Anyway, so let me let me see keep continuing to go over 4.3. So now here, see, okay, in this example, so I told you these two guys must be linearly independent, right? So then how can you figure out the two solutions are linearly independent? Then I introduce the Wronskian, right? So if you see, so if y1 of t and the y2 prime of t, okay, I mean y1, y2, let's say y1, y2 are solutions, okay, solutions. I'm not saying general solutions, okay? So y1, y2 are just solutions, okay? So then y1 times y2 prime minus y1 prime times y of t, sorry, here y2 of t is equal to 0. Then they are linearly dependent. Keep in mind this, okay? Then, I mean, y1 and, you see here, y1 and y2 are linearly dependent. Okay, linearly dependent. So, and then this one, that one is called the Wronskian. Okay, Wronskian. Wronskian of y1 and y2, yeah. Okay, keep in mind this. Okay, so sometimes you may be asked to you may be asked to figure out two solutions are linearly dependent or independent. Then you have to figure out Wronskian, and then try to figure out this guy Wronskian is equal to 0 or not. If that turns out to be 0, that means two solutions are linearly dependent. If not, linearly independent. Okay. So example is this. From example for this one. So the y1 of t is defined as cosine t, and then times sine t, and y2 of t is defined as sine 2t. All right, so determine whether two functions y1 and y2 are linearly dependent on 0, 1. That's question, okay? Determine whether the functions y1 and y2 are linearly dependent on 0, 1. Then what? We have to find a Wronskian, right? We have to calculate Wronskian, I mean. So Wronskian, yeah, so to get Wronskian, definitely we need to see here y2 prime and y1 prime. So we got to find the derivative y1 and y2. So y1 prime t is going to be what? We got to use a product rule, right? So derivative cosine t prime sine t, and then plus cosine t times sine t prime, right? Okay, that's why, I mean, this is equal to derivative cosine is negative sine, so we got negative sine t squared, right? You see, and then plus, and then derivative sine is a cosine, right? So we got cosine t squared. You see, okay, and then y2 prime is going to be 2 times, is it, because we got to use the chain rule, right? 2 times cosine 2t, right? Okay. All right, so we plug in y1, y2, y1 prime, y2 prime into the Wronskian. Okay, so then y1. Oh, can you cannot see that? Okay, so you can see. All right, y1 times y2 prime minus y1 prime times y2 is equal to. So y1 times y2 prime. Okay, so we got cosine t times sine t, and then y2 prime is 2 times cosine 2t, right? The minus y1 prime is minus sine t square, and then plus cosine t square, and then y2. What was y2? Yeah, sine 2t. Sine 2t. All right, so that is equal to, let's see. Give me a second. Okay, so we got, all right, I think you have to use the trigonometric identity. Cosine, okay. What? Remember that? Oh, we have here, right here. Sine 2t is equal to what? 2 times sine t times the cosine t. Okay, so I'll use this. Or you can use cosine 2t is equal to cosine t square minus sine. Ooh, can you see that? Okay. Yeah, sorry. Okay, sine t square. Okay, you can use. Oh, where that comes from? Yeah, I'll give me a second. I'll give the trigonometric identity. Okay, so sine is sine. This is really useful, and you have to memorize it. Okay, sine a plus b is equal to sine a cosine b. Okay, and then plus cosine a, and then sine b. Okay, and then cosine a plus b is equal to cosine a cosine b minus sine a and a sine b. Okay, so yeah, so how can you memorize it? You may just memorize this one as like this: sine a plus b is a SCCS. Okay, SCCS. Oh, and the cosine a plus b is a CC minus SS. Okay, but yeah. So, but what about the tangent? A plus b. Okay, so yeah, tangent a plus b is 1 minus tangent a tangent B, and then tangent A. Oops, it's tangent. Okay. Plus tangent B. Okay, so yeah, so tangent is a little bit complicated. So yeah, you don't have to memorize it, but these two guys are really important. Again, and the other one is this sine, a sine A squared plus cosine B squared is equal to 1, right? So this is really useful also. Anyway, so back to the problems. So let's keep in mind this. Okay, so all right. So if you missed it, it's okay because I'm recording this lecture, so I'll post in I think YouTube. All right. Okay. So I'll post in the link in the Blackboard, so don't worry about that. Okay. So back to the problems. So you see that sine 2t. So I'm gonna plug in 2 times sine t times 2 times the sine t times cosine t into sine 2t. Okay. So what happened? Then we're gonna get the cosine. And then I'm gonna plug in cosine squared minus sine squared into the cosine 2t right there. Okay. All right. So then we're gonna get the what? This is equal to this guy. You see that this is a 2 times sine times cosine, right? So 2 times sine t and then cosine t, and the cosine 2t gonna be what? Cosine t squared minus sine t squared, right? And then minus sine 2t is what? 2 times sine t cosine t. 2 times sine t and then cosine t, and then the bracket. I'm going to switch them out, okay? So we got the cosine t squared minus sine t squared. Okay, so this should be 0, right? That should be 0. So it turns out that Wronskian equals 0. It means that what? Two solutions are linearly dependent. Okay, so what's the answer? y1, y2. You see y1 and y2 are linearly dependent. Okay, linearly dependent. Okay, so now next one, so and then we gonna move to 4.4. Okay. Yeah. Okay. 4.4. So give me a second. I'm sure that you guys can see my lecture, right? The problem is this: I don't see my lecture. Huh. Anyway, it's okay. All right. So now what we're gonna do? Let's see, 4.4. So okay. So 4.4 is the method of undetermined equation. I mean, so we wanna 4.4. We wanna solve the non-homogeneous differential equations. Then we apply that method. Okay, so I'm gonna explain this. So I remember that I little bit gave you the part of this method 2 weeks ago, but yeah, but yeah, so from now I'm not gonna I'll, instead of giving you just this is formula of that method, instead of that I'll just derive I'm gonna derive that method. Okay, so from the scratch. Okay, so I mean nothing. So non-homogeneous differential equation has a form A, definitely the non-homogeneous with a constant coefficient. Okay, ay dot prime plus by prime plus cy is equal to f of t. So you see that f of t is the source function. This is non-zero function. Okay, So and then see, starting from this, what we did last time, in 4.1 to 4.3, we just guessed solution. Okay. So in the example, y double prime plus 2y prime plus y is equal to t. All right. So we want to solve this differential equation. As you can see that the source function, external force, is non-zero function. So what are you going to do? Okay. So we just guess. Okay. So let's say y is equal to y1 is just a times t. Okay. I think I did go over this stuff, but let me do again. Okay. So now then what? Then let y1 is a times t. Then y1 prime is a, and y1 double prime is 0. Yeah, and then we plug in these guys into the differential equation, right? So to figure out a, because a is what? We need to figure out a. This is coefficient of t, right? Okay. So we need to figure out a. How can I figure out a? We plug in y1, y1 prime, y2, y1 double prime into the differential equation. So then what? Then we're going to get 0 plus 2 times a, and then plus a times t equals t. So here's the problem. So we see that a times t equals t. It means that a is 1, right? A must be 1, right? But what about this? If a equals 1, then we're going to get 2. But look at the right-hand side. There is no 2. So it cannot be equal to each other, right? So there is no there's no number for a, answer for a that makes this equation to be true, right? So so what's wrong here? Because our guess is wrong. Okay, this is wrong. Okay, so now so we do second guess. As I said, this is the first guess. Okay, first guess. Oops. Okay. So second guess. Okay, second guess. So yeah, and let's say y2 is equal to a plus dt. So look at the first case. The reason that a times t cannot be the solution, because a must be 1 and 0 at the same time, right? So it means that we need one more unknown value. Okay, so that's why I put a, right? That's why we got a and b. Okay, so now then y2 prime gonna be b, and then y2 double prime gonna be 0, right? All right, so then we got 0 plus y2 times y2 prime is a b, and then c times a plus, oh, no, not c, hold on. Just a plus b times t equals t. Okay, so this is y second derivative. This is 2 times y prime, and then this is y. So then we got a 2b plus a, right? And then plus b times t equals t. It means that b must be 1. Oh, can you see that? Oh, sorry. I'm sorry. Okay, so then b must be 1, and then 2b plus a must be 0. Okay, so we got the system of equation for b and a, and then b is 1, so a must be what? Negative 2, right? So we got solution y 2 of t is equal to negative 2 times t. Oh, oops. Sorry, negative 2 plus t. Okay. So this is solution. Okay. So we want to generate this. So look at the back to the problems. So external force is, this is what actually the first order. Just simply saying the polynomial, right? Polynomial of degree 1, right? Degree 1. Okay. Right. then if this external force is has the form of polynomial of degree 1, then solution solution form should be the polynomial of degree 1. Okay, so now in general, let's see. So can you say that here? Okay, so in general, what for differential equation, I mean second order non-homogeneous prime plus cy not prime, I'm sorry, it's cy is equal to c times t to the m's power. I mean this is, yeah, I'm sorry, the polynomial, but let's say just monomial. Okay, monomial. Okay, so monomial, it's the external force is a monomial of degree 1. Okay, so general form of the monomial of degree m is this, right? C times t to the m's power. So the m could be 0 and 1 and 2 and okay. Then the solution, I'm saying that just solution. I'm not saying the general solution. Okay, so it's really far from here to find out general solution. Okay, so it's just beginning, of the journey to find out the general solution. So then the solution going to be, let's say it's P. Okay, P doesn't say, keep in mind this here, P doesn't say that, doesn't mean the particular solution. Okay, why P means just a solution. Okay, don't be confused that. Okay, so P doesn't mean the particular solution. We are not solving initial value problems. Keep in mind this. So P means just a solution. So this is equal to A times, I mean, so see monomial right there, right? So degree m monomial, then our solution, the form of the solution should be degree m polynomial. Okay, so am and t to the m's power plus am minus 1, t to the m minus first power, and then plus through the a1, and then t plus a0. Let's see, okay. So here's the problem then. How can you find out here? Yeah, okay. So the form of the solution is like, a form is like this. Then what about am and am minus 1, all these coefficients? These are called the what? Undetermined coefficient. Okay, undetermined equation. Okay, so then how can you find out these undetermined coefficient? So back to the example right here. How excuse me, how did we find the undetermined coefficient? Is here a b. In this example, we just plug in, right? We found the y2 prime, y2 double prime, and then plug them into differential equation, and then we got the system of the undetermined coefficient, right? So yeah, we're gonna do it that way. Okay. So, but anyway, I'm gonna explain in detail later. So now let's see. Here's a question then. Okay. Let me do xi. Okay. So right. All right. So now then, here's a question. Here's a question. What if f of t is not just polynomial? Okay. I mean, f of t could be exponential function or a sine function, cosine function, or simply power function, or a combination of exponential functions and polynomial functions. You know, there are lots of possibility, right? So then, for example, then, you know, in this pattern, you see here, we got this. So, oh, it's blurry, right? Oh, sorry. Hey, come on. It's still, oh, okay. All right. All right. Yeah. Okay. So here, the what? C times t to the m's power. I mean, the external force is just monomial, then general solution has the form the polynomial m. So the polynomial in similarly, can you say that f of t, I mean external force is just exponential function, then the solution, the form of solution, the form of a solution must be exponential form? Not always true. Okay. Okay. So here's the example, counter example. So let's see that example 2. Yes, example. All right. So let's find a solution of that differential equation. Definitely non-homogeneous to t. Okay. We don't have much of time, but okay. So I'm gonna explain. I'm gonna solve this example, and then yeah, just clear the day. Okay. So any announcement, I'll send the I'll let you know any announcement through the email. Okay, so please check your email very often. Okay, so here and then the okay solution right there. So let's say, I mean, a solution as the form a times e to the 2t. Where that comes from? Where that gas comes from? That gassing comes from the what? F of t, external force. So since external force is exponential function, so we kind of create a solution which is resemble to that external force, a times e to the 2t. Okay, I told you this is a counter example. Okay, so then yp prime is 2 times a times e to 2t, and then yp double prime going to be 4 times a times e to 2t, isn't it? Right. Okay, so now then, yeah, what are we going to do? Yeah, you know what? You know that, right? So we plug in yp prime, yp double prime into differential equation. So then we got e to the 2t, and then isn't it? Oh, give me a second. Not e to 2t. Oops, sorry. So it's gonna be 4 times a times e to the 2t. That's a yp double prime, right? Plus yp prime gonna be 2 times a times e to the 2t. And then plus 2y gonna be 2 times a times e to the 2t. Yes, is equal to 5 times e to the 2t. Okay. Give me a second. Oh yeah, I think I gave a wrong example. Okay, let me go. Okay, this is not counter example. I'm sorry, I was confused with other example. Okay, so this is not a counter example. Sorry. So that example works. I mean, the if that could be a solution. Okay, I'm sorry. So this is for. Let me finish this. 4a plus 2a plus 2a times e to the 2t is equal to 5 times e to the 2t. So then we got the what 4 2 to 8a, right? 8a e to the 2t is equal to 5 e to the 2t. So a must be what 5 over 8, right? Yes. So that works. Okay. All right. So but let's see that other example. So y double prime minus 6y prime plus 9y is equal to e to 3t. Okay. All right. Then similarly, we can say y a solution going to be a times e to the 3t. Okay. Then yp prime going to be what? It's going to be 3 times a times e to 3t, right? and the yp dot prime is going to be 9 times a times e to 3t, right? All right, so then yp dot prime minus 6 times yp prime plus 9 times yp yp going to be what? 9a e to 3t, and then minus 6 times 3 times a times e to 3t, right? And then plus 9 times a times e to 3t. That is equal to e to 3t, right? Okay, but here's the problem. You see that? So this is what? Simplifying, this side, what we're gonna get? 9a minus 18a plus 9a times e to 3t, which is 0, right? 0 times e to the 3t is equal to e to 3t. So this is not true, right? So for any choice of t, we're gonna get a false equation, right? So y1, that solution, that this form of solution cannot be a solution. So you see, this is a counter example. So here we wanna investigate why, you see that here, that example, it works, right? We just said a solution has a form a times e to 2t and the e to 2t from the external force right here. That works, but why that example doesn't work? What's the difference between that example and this example? We need to investigate. Okay, so I'm gonna go over that stuff. Okay, this one next time. Okay, so let me stop here. All right. So if you have any questions, yeah, just send the email or yeah, just let me know by the Zoom here. Okay, the meeting. Anyway, so okay, I'll stop recording.